everyone, so in this video we're going to do a brief introduction to rational functions, rational equations, expressions, and then also just do a little bit of simplifying, just kind of some simplifying of rational expressions. Remember, a rational number is basically any number that's a fraction. Rational means ratio, so it's a ratio, a fraction, like 2/7 or -1/9. Or even like 5 is a rational number because it's 5/1. So rational expression is the same thing, but there might be some variables in there. It's any sort of usually a fraction made out of expressions. So it's a fraction where the numerator and denominator are some sort of polynomial. Just like each of these are rational expressions. So just like we often do in algebra, it's helpful to sometimes simplify these rational expressions, so that's what we're going to talk about now. But first I do want to show you quickly the parent graph for a rational expression. The parent function, kind of the most simple rational function we could come up with, is 1/x. I don't know if you can see that. And the graph actually looks like this. It's in two pieces. It has a horizontal asymptote at 0, and it also has a vertical asymptote at 0, and so it forms kind of these two pieces. And if you plugged in values to x, you would see why. Basically, the bigger the number that you plug in for x, the smaller the output is. And it also can't hit at 0 because if you were to plug in a 0, you can't divide by 0. And so that's actually why there's a vertical asymptote here, is because it can't. You can't plug in 0. All right. So I want to start with talking about what can we cancel. It's really tempting to many algebra students to try to cancel terms like those. It's like, oh, there's an x on the top and x on the bottom, so can't I cancel those? And you cannot. You can only cancel variables or numbers if it's all just multiplication and division. So anytime you have addition and subtraction, I would have to cancel out this entire thing. If I were going to cancel out 2 plus x, I would have to have an entire 2 plus x on the bottom that I could then cancel out. But as it currently is, this x is attached to the 2. There's kind of some understood parentheses around the numerator and denominator that we don't usually write. And so that x is attached to the 2 by the plus sign. But here I've got a 2 times x divided by x, and they're just being multiplied, so I can cancel the x's. So as long as it's all just multiplication, as long as it's all just factors, you can cancel stuff, but pluses and minuses usually complicate things. So I wanted to kind of show you why. 66/63, let's say we broke that up to be 60 plus 6 and 60 plus 3. And then imagine I was like, oh, I can cancel the 60s, which you can't actually do this. That would tell me that this is 6/3, which is just 2. And I know that this is going to be close to 1. It's going to be a decimal. It's definitely not 2. So this kind of is more of a better demonstration of why you don't want to do what I just did here. What you want to do is go ahead and add them first and then divide them, because like I said, there's really some understood parentheses here. So same thing when there's variables. You can't just cancel those x's because that's attached to the +4 and that's attached to the +2. The only time I could cancel is, let's say this was an x plus 2 up here, and now that it's just multiplication, I could cancel out the x plus 2's. So again, you can only cancel factors, like when there's multiplication, not terms. I can't cancel out these x's or these 60s. So just be careful with that. All right, so we're going to go through a few examples of simplifying. Since this is all just multiplication and division, I can cancel things. 4/6 simplifies to be 2/3 if you divide them both by 2. And the x stays on top, but if I have 2 y's down here and I cancel out one of the y's on top, 2 minus 1 leaves 1 y on the bottom. Or like on this one, the 2 stays on top, and I have 2 x's on the bottom and 1 x on the top, so 2 minus 1 leaves 1 x on the bottom. Here's a few more. So 18 over 12, if you divide those both by a 6, you would get 3 halves, and then 3 x's cancel out, one of them leaves x squared. On this one, by the way, if you have a negative in the denominator or in the numerator, that makes the whole thing negative. Of course, we don't want both to be negative, then it will be positive, but the negative can go down here or just kind of in the middle or on top. It really doesn't matter where that negative goes. But 75 over 5, let me divide that real quick, is 15. So this whole thing becomes 75 over 5 is 15. That could go in the front or just on top. It is still negative. You could leave it in the bottom if you want. I'm just going to put the negative in front. And then 3 a's cancel out, 1 leaves a squared. And if I have 6 b's on the bottom but subtract 2, that leaves 4 b's on the bottom. And on this one, I can't cancel anything because this is kind of attached with the plus. This is attached with the plus. I could factor out an x, but that's not really going to help at all. So there's nothing I can do on that one, nothing I can cancel. On this one, it's like this stuff is all attached, yes, but I could break it up over that denominator if I wanted to maybe try to cancel some things. For example, like if I have 2/5 plus 1/5, that's the same as 3/5. Because 2 plus 1 is 3. And so basically, it's the same as 2 plus 1 over 5. All of these are equal. So, all that to say, if I wanted to take this and go back to here, I could just break up that numerator over their same common denominator. And so we could do that with algebra as well. I can take 10x squared minus 13x and put them both over 4x. This isn't going to help a lot, but I can cancel a few things. 10 over 4 becomes 5 halves. X squared over x becomes just x. And then the 13/4 will have to stay, but I can at least cancel out both of those x's. So there we go. That's my final answer. And you could combine it back into one if you wanted. All right, just a few more of this, kind of breaking it up. Again, I can't cancel those 2's, but I could break up the 2 minus 12x to both be over this denominator here, which would simplify quite a bit. That would be a 1 minus 6x. Same thing here. We could do 18x to the 4th minus 10x squared plus 6x to the 7th, and put them all over 2x squared. So let's simplify each one of these. That's going to be 9x squared. This will be minus 5. And those x's just totally cancel out. And then 6 over 2 is 3. 7 minus 2 leaves me 5 x's. All right, none of those are like terms, so that is my final answer there.